In today's lesson, I'm going to talk about literal equations, and then Steve and Ann are going to talk about modeling and solving word problems using algebra. I'm going to start with a definition of what a literal equation is. And then I'm going to spend the rest of my part of the lesson solving for a variable. This is a skill that's useful not only in this class and future math classes, but also in your science classes. So let's start with a definition of a literal equation. A literal equation is just a formula or equation containing two or more variables. A equals LW is a literal equation. It's just a formula for finding the area of a rectangle. F equals 9/5 C plus 32 is another literal equation. This allows us to convert from Celsius temperatures to Fahrenheit temperatures. So let's talk about solving for a variable. Let's start with the formula C equals pi times d. I want to use this formula to find the diameter of a tree of circumference 10 pi feet. So I'm given that the circumference is 10 pi. So I can substitute 10 pi for C in my formula, which gives me 10 pi equals pi times d. Now if I want to solve for d, the diameter, I would need to divide both sides of the equation by pi. When I do that, I get 10 equals d. That tells me that the diameter of the tree is 10 feet. What if I had a tree of circumference 7 feet? So now C is 7 pi feet. So C is 7 pi. Substituting 7 pi for C in my formula, I have 7 pi equals pi times d. If I want to isolate d, I need to divide both sides of the equation by pi. So 7 pi over pi equals pi d over pi. Simplifying, I have 7 equals d. This tells me the diameter of the tree is 7 feet. What if the circumference of the tree were 5 feet? So now C equals 5. So in my formula, substituting 5 for C, I have 5 equals pi times d. To solve for the diameter d, I need to divide both sides of the equation by pi. Pi times d over pi. This gives me 5 over pi equals d. So I know the diameter of the tree is 5 divided by pi feet. Not a very user-friendly number. If you want, you could get an approximation for the diameter by dividing 5 by pi on your calculator. I'm going to leave this in exact form so that I know the exact circumference of the tree. This is actually a more reasonable example than the first two. If I were to go out and measure the circumference of a tree, there's no way I could measure a circumference of 10 pi or a circumference of 7 pi. Remember, pi is an irrational number. I could, however, go out and measure a circumference of a tree as 5 feet. So I've just found that the diameter of this tree is 5 divided by pi feet. Well, let's think about this in general. Let's use the formula C equals pi over d, pi times d, to find the diameter d of a tree of circumference c feet. So if I want to find the diameter of a bunch of trees in an area, and I go out and measure a whole bunch of circumferences, I could go through and do several calculations like I just did. If I had a circumference of 10 pi, I had to divide both sides of the equation by pi to find the diameter. If I had a circumference of 7 pi, I had to divide both sides of the equation by pi to find the diameter. When I had a circumference of 5 feet, I had to divide both sides of the equation by pi to find the diameter. So let's do that in general so that I don't have to keep repeating this calculation over and over again. So I have my formula, c equals pi over d. To solve for d, just as I did with the numerical examples, I'm going to divide both sides of the equation by pi. And this gives me c divided by pi equals d. Now I have a formula that if I know the circumference of a tree, which is a lot easier to measure than the diameter of a tree, I can just plug in that value for c and divide it by pi. I don't have to solve an equation for d over and over again. Here's another formula, I equals PRT. This is a simple interest formula. I represents interest, P the principal, R the rate, and T the time. I'm asked to take this formula and solve it for the rate, R. Well, the first thing I'm going to do is rewrite this a little bit using the commutative property of multiplication. So another way I can write this formula is I equals P times T times R. The only reason I'm doing that is to look at this in a little bit different way. Now I can think of PT, or P times T, as being the coefficient of R. So if I want to isolate R, I need to divide both sides of the equation by PT. So I divided by PT equals PTR divided by PT. And this gives me I divided by PT equals R. If you prefer, you can use the symmetric property of equality and rewrite this as R equals I over PT. Either way, you have a formula solved for R. Something important to note here is that you need to know which variable you're solving for. In this formula, there were 4 different variables. I could have been asked to solve for P, R, or T. Well, now let's think about how we can use the formula F equals 9/5 C plus 32 to find a formula which converts from Fahrenheit temperatures to Celsius temperatures. Now you might be thinking here, okay, if I know the Fahrenheit temperature is 80 degrees, all I'd have to do is substitute 80 for F and solve for C. But what if you had a whole bunch of temperatures to convert? Wouldn't it be easier to have a formula that gives an output of C? You put in some number for F and get out the Celsius temperature. Then you don't have to go through and use your formula and solve for C over and over and over again. So that's what I'm going to do here. I'm going to solve F equals 9/5 C plus 32 for C. Then I'll have a formula for converting from a Fahrenheit temperature to a Celsius temperature. So I want to isolate C. I'm going to start by isolating 9/5 C. To do that, I will subtract 32 from both sides of the equation. That gives me F minus 32 equals 9/5 C. Now to isolate C, I need to multiply both sides of the equation by the reciprocal of 9/5, which is 5/9. So 5/9 times F minus 32 equals 5/9 times 9/5 C. Now I could distribute this 5/9 through to the F and the 32, but I don't need to. All that I'm looking for is a formula that gives me Celsius temperatures in terms of Fahrenheit temperatures. All that I'm looking for is a formula that's solved for C. That's what I have here. If I distributed the 5/9 through, I'd also have a formula that's solved for C. Well, here's an equation that we're going to see quite a bit later in the term. We're asked to solve y equals mx plus b for m. It turns out that y equals mx plus b is an equation that when we graph it, we get the graph of a line. I want to take this equation and solve it for m. To do that, I'm going to start by isolating the term that involves m, that is the term mx. So I'm going to subtract b from both sides of this equation. If I do that, I'm left with y minus b equals mx. Now I'm trying to solve for m, so I need to get rid of the x that's being multiplied by m. I can do that by dividing both sides of the equation by x. And this gives me y minus b over x equals m. And this is fine. This formula is now solved for m. If I want, I can stop right here. What I want to point out, though, is sometimes when you go and check a problem like this in the back of the book, the form of the answer might look a little bit different in the back of the book. And you want to be able to tell whether or not the solution that you came up with is equivalent to the solution in the back of the book. There's something that I could do to rewrite this formula. I could separate the left-hand side into two fractions. So I could say that y over x minus b over x equals m. That would be fine also. It's still a formula solved for m. And of course, we can always use the symmetric property of equality to switch the left and right-hand sides. So we could put the m on the left-hand side and the y over x minus b over x on the right-hand side. The equation 3x plus 2y equals 7 happens to be another equation that if we graph it, it turns out to be a line. Looking at it in this form, it's not obvious that this is of the form y equals mx plus b. What I'm being asked to do here is solve this for y. And if I solve this for y, I think I'll be able to show you that this is actually an equation of the form y equals mx plus b. So I'm starting out with the equation 3x plus 2y equals 7. I want to isolate y, so I'm going to subtract 3x from both sides of the equation. If I do that, then I'm left with 2y on the left-hand side equals 7 minus 3x. Now I want to isolate y, so I'm going to divide both sides of the equation by 2. So 2y divided by 2 equals 7 minus 3x divided by 2. And that is y equals 7 minus 3x divided by 2. Now if you're thinking, you just told me you were going to show me this was of the form y equals mx plus b. Well, in this form it doesn't look very much like that, does it? So what I'm going to do is first separate this into two fractions. Y equals 7 halves minus 3 halves x. Then I'm going to take one more step. I'm going to think of this as addition, 7 halves plus negative 3 halves x, and use the commutative property of addition to rewrite my terms in the opposite order. So y equals negative 3 halves x plus 7 halves. Now if we look at this, we have something of the form y equals mx plus b, where m happens to be negative 3 halves and b is 7 halves. Here's another formula, a equals bh divided by 2. I want to solve this for b. Now you might recognize this as being the formula for finding the area of a triangle of height h and base b. If you don't, that's okay too. All that we're being asked to do here is solve for b. So I have the formula a equals bh divided by 2. I want to solve for b, and right now I see that the b is trapped in the numerator of the fraction. So the first thing I'm going to do is eliminate the fraction altogether by multiplying both sides of the equation by 2. This gives me 2a equals bh. 2 divided by 2 is 1. 1 times bh is bh. Now I'm trying to solve for b, so I still need to isolate b. Right now, h is being multiplied by b, so if I divide both sides of the equation by h, I can isolate b. So that gives me 2a over h equals b. And of course, if I want to, I can rewrite this as b equals 2a over h. Here's another formula from geometry. A equals h over 2 times the quantity b sub 1 plus b sub 2. Notice we're using subscripts here. B sub 1 and b sub 2 are two different variables representing two different things. These are different than superscripts. If we had something like x squared, the 2 is sometimes referred to as a superscript. That indicates a power or an exponent. This formula gives us the area of a trapezoid with bases b sub 1 and b sub 2. The b sub 1 and b sub 2, again, are indicating that the bases of a trapezoid have two different lengths. And then h represents the height of the trapezoid. So let's take this formula and try to solve it for b sub 1. So my formula is a equals h over 2 times the quantity b sub 1 plus b sub 2. Looking at this formula, there's a couple of things that I could do here. I could distribute the h over 2 through the parentheses to the b sub 1 and b sub 2. If I did that, then I would have two terms involving fractions, and I'd have a bunch of fractional arithmetic to do in my solution process here. So instead, I think I'm going to do the same thing I did with the formula for the area of the triangle. I'm going to start by eliminating the fraction. So I'm going to multiply both sides of this equation by 2. So 2 times a equals 2 times h over 2 times the quantity b sub 1 plus b sub 2. When I do that, I have 2a on the left-hand side, and on the right-hand side, since 2 divided by 2 is 1, and 1 times h is h, I'm just left with h times the quantity b sub 1 plus b sub 2. Once again, I've got a couple of choices here. I'm trying to solve for b sub 1. b sub 1 is inside the parentheses here. So with this h, there's a couple of things I can do. I can distribute the h to b sub 1 and to b sub 2, or I could divide both sides by h to move the h to the other side of the equal sign. I'm going to make a choice here, and I'm going to distribute the h through to the b sub 1 and b sub 2. That gives me 2a equals h b sub 1 plus h b sub 2. Now again, just to remind myself, I'm solving for b sub 1 here. So I'm going to isolate first of all the term h b sub 1 by subtracting h b sub 2 from both sides of the equation. So 2a minus h b sub 2 equals h b sub 1 plus h b sub 2 minus h b sub 2. This gives me 2a minus h b sub 2 equals h b sub 1. I still need to isolate b sub 1. I can do that by dividing both sides of this equation by h. So 2a minus h b sub 2 over h equals h b sub 1 over h. So I have 2a minus h b sub 2 over h equals b sub 1. Now I want to show you what would have happened if instead of distributing the h through the parentheses when I had 2a equals h times the quantity b sub 1 plus b sub 2, instead if I had divided both sides of the equation by h. So if I had made the choice to divide both sides of the equation by h, I would have ended up with 2a over h equals b sub 1 plus b sub 2. Then the only thing I'd have to do to isolate b sub 1 is subtract b sub 2 from both sides of the equation. What I would have ended up with is 2a over h minus b sub 2 equals b sub 1. Remember, it's important to be able to recognize different forms of a formula that are equivalent. What I got the other way was 2a minus h b sub 2 over h equals b sub 1. These two formulas are actually equivalent. If I took the formula that I came up with and broke the left-hand side up into two fractions and simplified, I would come up with 2ah minus b sub 2 equals b sub 1. It's a good idea to go ahead and verify that for yourself. Now let's look at the formula p equals 5c plus mc. We want to solve this formula for c. Well, the first thing I'm going to do is I'm going to think about a little bit simpler problem. So what if I had p equals 5c plus 7c? 5c and 7c are like terms, so I could obviously just combine the like terms together and come up with 12c. Something we often talk about when we're first learning combining like terms is how we can use the distributive property to combine like terms. So I could write this as p equals the coefficients 5 plus 7 added together times c. What we're essentially doing here is using the distributive property in reverse. We call this process factoring. I want to do the same thing with the formula I was given, p equals 5c plus mc. So using this same strategy, I'm going to take my coefficients of the two terms involving c, which are 5 and m, and write those in front in parentheses, 5 plus m, that quantity, times c. Again, this is just the the distributive property used in reverse. We call this factoring. So now if I want to isolate c, c is being multiplied by the quantity 5 plus m. So I can divide both sides of the equation by 5 plus m. So p divided by 5 plus m equals the quantity 5 plus m times c divided by 5 plus m. Now if you're thinking to yourself, why aren't there any parentheses around the 5 plus m's in the denominators? Well, remember the fraction bar works as a grouping symbol, so the fraction bar is placing both the 5 and the m in the denominator. I still do need the parentheses in the numerator. The parentheses in the numerator indicate that c is being multiplied by both 5 and m. So simplifying, I have p divided by 5 plus m equals c, and now I have a formula solved for c. Let's solve the formula k plus ab equals a for the variable a. Well, the first thing I notice here is that I have an a on both sides of the equal sign. So what I want to do as my very first step is to move both of the terms involving a to the same side of the equal sign. Since the only term that doesn't have an a is the k sitting by itself, I'm going to leave k on the left-hand side. I'm going to move ab to the right-hand side by subtracting ab from both sides of this equation. When I do that, I'm left with just k on the left-hand side equals a minus ab. Now I'm running into a situation where I have a in two different terms, just like the last example. So what I want to do is use a similar tactic. I want to use the distributive property in reverse. Or another way I could word this is I'm going to factor out the a. So if I pull out an a in front, set up my parentheses that I use with the distributive property, well, this first a I can think of as having a coefficient of 1. 1 times a is a. We just write a. We don't write coefficients of 1. So I'm going to write my coefficient of 1. I have a subtraction. In the term ab, even though the b is not written in front of the a, I can think of the coefficient of a as being b. So in my parentheses, I have 1 minus b. The nice thing about this process is we can now use the distributive property to check that we've done this correctly. When I distribute a through the quantity 1 minus b, I better get a minus ab. Well, a times 1 is a. That's okay, that's what I want. Minus a times b is ab. So this checks. So now I have a being multiplied by the quantity 1 minus b. I want to isolate a. So I'm going to divide both sides of the equation by the quantity 1 minus b. So k divided by 1 minus b equals a times the quantity 1 minus b divided by 1 minus b. So simplifying, I have k divided by 1 minus b equals a. And my formula is solved for a. Here's a formula we could use to average three numbers, x, y, and z. We're being asked to solve this formula for z. So I have a equals x plus y plus z over 3. I want to solve this for z. The first thing I'm going to do is eliminate the fraction, so I can get to that z that's right now trapped in the numerator of the fraction. So I'm going to multiply both sides of the equation by 3. Simplifying, I have 3a equals x plus y plus z. I want to solve for z. To do that, I can subtract x from both sides of the equation, and then subtract y from both sides of the equation. Or I can do that all in one step. So I'm going to subtract x and subtract y from both sides of the equation. That gives me 3a minus x minus y equals z, and the equation is solved for z. Well, in my last example, I want to look at another type of averaging formula. You can use the formula a equals t sub 1 plus t sub 2, subscripts again, so indicating two different variables, plus 2f, all divided by 4 to figure out the score you must earn on your final exam to earn a particular grade if your tests are worth 100 points each and your final counts twice. Well, student after student after student keeps asking me, what score would I have to earn on the final in order to earn an A test average? Or what score would I have to earn on the final to earn a B test average? Well, I want a formula to give them so that they can figure it out for themselves. So what I'm going to do is I'm going to take this formula and solve it for F, F representing the grade they would need to earn on the final. So I see that F is trapped in the numerator of this fraction. I'm going to start by eliminating the fraction. I'm going to multiply both sides of the equation by 4. This gives me 4a equals t sub 1 plus t sub 2 plus 2f. I want to isolate f. I'm going to start by isolating the term involving f. So I'm going to subtract t sub 1 and t sub 2 from both sides of the equation. And that leaves me with 4a minus t sub 1 minus t sub 2 equals 2f. Now to isolate f, all I need to do is divide both sides of the equation by 2. So 4a minus t sub 1 minus t sub 2, all divided by 2, equals 2f divided by 2. So now I have my formula 4a minus t sub 1 minus t sub 2 divided by 2 equals f. My formula is solved for f. Well, now go ahead and use my formula to determine what score you would have to earn on the final in order to earn an A test average. That's at least 90 in my class. So if you earned 83 on your first test and 95 on your second test, what would you have to earn on the final in order to earn an A test average? So here's the formula that I just came up with, 4a minus t sub 1 minus t sub 2, all divided by 2 equals f. You earned a score of 83 on your first test, 95 on your second test. You're interested in what should your score on the final be, for your test average to be at least 90. Well, when I see the words at least, I think inequality. I know that my test average, that's the variable a here, needs to be at least 90. So I want a to be greater than or equal to 90. Well, the problem with my formula, the way that it's written, is that a is trapped in the numerator of the fraction. There's no way I can build that inequality here. So what I'm going to do instead is solve an equation. I'm going to figure out what is the minimum score to earn on the final in order to have an A test average. So I'm going to just set A equal to 90, even though I know I want A to be 90 or greater. And we know that t sub 1 is 83 and t sub 2 is 95. So if we have all of these conditions, then f is going to be 4 times a, 4 times 90, minus t sub 1, that's 83, minus t sub 2, that's 95, all divided by 2. Well, I'm going to pull out a calculator to do this calculation. So I need to take the quantity, using parentheses for my numerator, 4 times 90 minus 83 minus 95, that whole quantity divided by 2. And I see that that equals 91. So here I get f equals 91. What I need to remember here is that f is the minimum score that I could earn on the final in order to have a test average of at least 90. So if I earned anything 91 or greater on the final, then my test average would be at least 90. So you need to earn a score of at least 91 on the final to earn a test average of at least 90. Now I'm going to turn this over to Steve, who's going to look at some word problems using algebra.